Hi and welcome back to our subject matter. This time we'll be talking about the derivation of the derivative of sine x, which is cosine x. But before going directly to the proof of the derivative of sine x, which is cosine x, you should have the prerequisite knowledge here in your previous subject, especially in precalculus and in trigonometry. Okay, so the first thing that you should remember in the past will be the limit of sine of an angle over an angle as that angle approaches 0 is always equal to 1. Okay, I know you know that in your previous subject. And the second one here is the limit of the cosine of an angle minus 1 over that angle as that angle approaches 0 is always equal to 0. Okay, so those two important limits in precalculus will play a very important role in our proof here of the derivative of sine x. Another background that you should remember in your trigonometry will be the sum and difference formulas for two acute angles. Here in the first one, if you encounter the sum of two angles, you should have the product of the first and the second, and also the product of the second and the first angle. And for cosine, this is equal to cosine A, cosine B, plus or minus sine A and sine B. So these four basic ideas that you have learned in the past or in your previous subject during your high school days, maybe in your senior high or other subjects, then we'll be using that in the proof of this derivative of sine x. So the question that we'll be discussing this time will be why the derivative of sine x is cosine x. I know that you have already the different rules for derivation of a function. For example, the simple power rule, the sum and difference rule, the product rule, the quotient rule, the chain rule, and implicit differentiation. But sad to say, all of those rules are not applicable in this proof because the only applicable derivation technique that we'll be using this afternoon is we'll go back to the very basic difference quotient formula, which is f prime of x is equal to the limit of as h approaches 0 of f of x plus h minus f of x all over h. Okay, so our given function, please remember, our given function is sine x. So if you'll be asking what is f of x plus h, just add letter h to x and then perform the function, which is sine x. So this will be equal to the limit as h approaches 0 of sine of x plus h minus f of x. And our f of x here is the given function, and the given function is sine x, right? Okay, all over h. So this time in the numerator we have sine of x plus h, and take note, if we are talking of trigonometric functions, it means that we are looking for the value of an angle. So in other words, letter x here and h are both acute angles in a triangle. So this is a sum. So in other words, we'll be using here our sum formulas. So because we have two angles, x and h. So if we will expand that one, this will be equal to the limit as h approaches 0 of sine of x times cosine of h plus cosine of x times sine of h. Okay, do not be confused with our expansion, and we are just using there the sum and difference formulas. And take note, here in the numerator we still have minus sine x because in our given problem here, our f of x is sine x. Okay, so all over h. Okay, so the next step that you will be doing here, because our numerator looks like a very complicated function, is to rewrite them in such a way that you could apply some simplification. So I will rewrite the numerator as sine x cosine h minus sine x plus cosine x sine h over h. There is a reason why I have written the numerator like this, because I know that the second step will be factoring. So I could factor out this sign outside of these two first terms in the numerator. For example, this sine x cosine h minus sine x, the common term is sine x. So we could pull out sine x, and the remaining terms inside the parentheses would be cosine of h minus 1, okay, plus cosine of x and sine of h all over h. This time, we are not yet ready to drop the limit sign because our given function, the right side, is not yet simplified. So this requires a little bit of algebra. So I will write again the given function as sine of x times cosine of h minus 1 over h, okay, plus cosine of x sine of h over h. What I did is I separated the numerator by a common denominator. So for example, in your algebra, we know that, for example, we have 1 plus 3 over 2. Okay, we could separate the fraction into 2, di ba? So I could separate this one as 1/2 plus 3/2. So same here in our problem, I have separated the numerator by a common denominator. So that's the result. Okay, continuing the process, I could rewrite again this one as sine of x times cosine of h minus 1 over h, and sine of x, the denominator would be 1, because 1 times h is h, and if we'll multiply the numerators, we'll go back to the original numerator. Same here with the other term. I could write here cosine x times sine of h over h, or I know you know this, that the denominator of cosine x is always 1, because 1 times h is also h. Okay? Question is, why did I rewrite the numerator or the terms in this way? I have written that because I know that cosine of h minus 1 over h is 0, based from our previous knowledge here in our pre-calculus subject. Remember this one? The cosine of an angle minus 1 over that angle, as that angle approaches 0, is 0. So I have rewritten our fraction in that type so that I could set an equivalent value for this as 0. So if we'll continue the process, we are ready now to drop the limit sign. So the limit of sine x as h approaches 0 is still sine x. Remember, our variable is h, and x here is not a variable because our variable here that approach 0 is h and not x. Okay, so we have sine x times 0. This 0 came from the limit of cosine h minus 1 over h as h approaches 0, plus the limit of cosine of x is still cosine of x, and this one, sine of h over h, is equal to 1. Okay, so this will become sine x times 0 is 0, of course, and then cosine x times 1 is cosine of x, and finally our f prime of x is equal to cosine of x. So this is now the derivative of our given function sine of x. So in other words, if somebody would ask you what's the reason behind why the derivative of sine x is cosine x, Well, the answer will be a short process, I think, in order for you to arrive at cosine x. Thank you very much, and see you soon on the next video. Thank you.